When I say grain, it's rice, wheat, and maize, which I call major food grains in the world. And the per capita availability was slightly above 100 kilograms per person. Now, that time we had 400 million people. Now we have 1.4 billion people, 1.4 billion people, and the per capita availability of grain is close to 200 kilograms. That actually tells what has happened in the Indian agriculture and the achievements we have made in the last 5 to 6 decades. We have proved the rest of the world wrong in terms of what India can achieve in agriculture. But despite this success, the lot of problems still exist, lot of constraints still exist, lot of emerging issues are popping up. So our problems are not over just because we produced and we achieved. We are feeding the populations. We have a lot of issues coming in, and a lot of issues remains to be solved. This is just to tell you the number of poor people live in different crop area of South Asia. And if you look at the rice, the number of poor people, number of people below poverty line is the highest. So the rice growing region is the poorest in the region. There are more than 200, 300 people now live in the rice growing area who are below poverty line there. In terms of the rural poor population, so you can see the extent of the poor population both in India, Bangladesh, and in the region there. So we are one of the region where the maximum number of poor people live. Despite all the success in agricultural revolution, production, food availability, the lot of poor people still remain in the continent there, in the subcontinent there. So you can see also the poor population per square kilometer, the deltas, the Ganges Delta, these are the regions where you see the maximum number of poor population per square kilometer there. Apart from the poor people there, availability of food and other products there, the poverty, the prevalence of malnutrition and the stunting and still exist in the country. If you look at India, that more than 30% of the kids below 5 years are stunted. That means they're malnourished, they're not enough balanced diet. So that is affecting the growth of these children there. So we have issue of poverty, we have issue of malnutrition. Those issues continue to remain despite the success of agriculture in the last 5 to 6 decades there. But there are a lot of things changing in agriculture, which is going to affect the graduates like you who are coming out of the universities to address this issue there. Our population continues to rise, urbanization happening. When urbanization happens due to economic growth, then your food consumption pattern also changes. You demand different type of food. You demand different type of more health conscious food. So that the food consumption pattern in the country, both in India and in other parts of the developing Asia, is changing very rapidly. So diet diversification is happening. So this is a big challenge for the agricultural graduate like you coming out to produce not just rice, wheat, and maize. The consumers are demanding different food. So you need to equip yourself to produce more high value products, more health conscious consumers, and more horticultural products, more other things there. And the other thing is a lot of people are moving out of rural areas. As you know, the agriculture is not a very attractive profession, both in India and in other parts of the world there, other parts of Asia also. The farmers now do not want its kids to go into farming. They want their children to go out and work for IT company, get a degree in engineering, work for somebody else. Even if they are not educated, they want them to go out, become a security guard, rather than going into agriculture there. So agriculture still is not a very attractive profession in developing world. So there are a lot of rural out migration happening. And when that happens, the young mass moving out of the region, then that is a big issue for agriculture. Who is going to manage the agriculture there? So the women and the old people left behind, they are the one taking a lead role in managing agriculture. And that has serious implication on agricultural scientists, particularly who are developing machines, who are developing different tools, agricultural practices. You need to ensure that the technology you develop are suitable for people who are doing the agriculture, particularly the women. women-centric agriculture, how machinery developed by graduates like you will be suitable for the women, because they are the one leading the show now. Slowly, they are the one taking over as a managerial role in agriculture there. And now the labor scarcity is there, and I think it's pretty evident in the southern part of country. We are now getting some labor from the eastern part of the country, Odisha, Bihar, northeast part of the country. But eventually that's going to change. Once the development happens in the eastern part of the countries, the labor which is flowing from east to either northwest or the south, it's going to decline. So the labor scarcity and rising wage rate will be already has become an issue and will become a bigger issue there. And that also creates a problem for the agricultural scientists. So you need to develop technologies which are not labor intensive, which are more optimized, which requires, so eventually the agriculture will require a lot less labor. The farmers will start using technologies to reduce the dependence on the labor there. So we have limited arable land, declining water table and climate change. I'll talk little bit on the climate change there, particularly, which is a pressing issue for India and many other developing and developed country in the world there. So the right side, I have a picture of Miss Chalao in Supanburi in Thailand. And she is still a farmer, but she has kind of ventured into a service provider, and particularly the combine harvest. And her machine moves not only in Thailand, it goes to Cambodia and other countries there. So she has become a regional service provider there. As a woman, she has, apart from farming, she has become a entrepreneur. So we'll see this type of things happening in India. It's already happening, but it will happening more evidently, that women taking a more primary role in agricultural production there. So this is what I was talking about, the outmigration happening, everybody moving to the rural urban area there. And India, it's already, in 2020, more than 50% people live in the urban areas. That's going to continue to happen. And by 2050, nearly 2/3 of the population will be live in the urban area, including India. So there will be 1/3 left in the rural areas. What it has implication both in terms of the agricultural production and also the food consumption. So it has implication how we produce food and what we consume. So as I said, the labor scarcity is going to drive the technology adoption in the agricultural sphere there, both in terms of the use of the digital technology, use of more machine, drone. We have already seen this happening all over the India or the region. And I think it's going to accelerate the adoption of the technology, both digital and the other technology will accelerate in the future, because that less people are living in the rural areas. But at the same time, urban people, 2/3 of the people who are living in the urban area, their food consumption also pattern is changing. They will look for more convenient, ready to eat food. And so we have to adopt ourselves to produce food which will be met, which will satisfy the demand of the urban consumers there. And other things, as I said, are the urbanization happening both in India and in the region there. So, you can see the Asia Pacific and the rest of the world and the number of middle class population. Asia Pacific in 2030, there will be 3.2 billion people, which India and China for the major part, there will be middle class, in the middle class population, which are driving the consumption pattern in the region there. And based of it, Asia used to be the richest region, continent in 17th century. You can see we accounted for 60% of the global GDP. But we became poor by 1950s. Our contribution to the global GDP was slightly below 20. Now we are on the rise again. So by 2030, it will go to 40% of the global GDP. And by 2050, Asia will account for more than 50% of the global GDP there. So we are regaining our past glory of a developed region, and which has serious implications on the food consumption and food production there, which the graduate of this decade or next decade or in the next 2-3 decades will have to resolve with so much rise in the income and the food consumption pattern there. So we have already seen the westernization of the Asian diets there. I don't think I really need to come to that. We are starting to consume both in India and outside more westernized food, more ready to eat food, more convenient food there. This is what I would like to. One of the things, the once we get wealthier, I just have a meat consumption, China versus India. Just look at the sheer disparity between the meat consumption. In China, it is close to 90 kilograms of meat, pork, chicken, beef, and goat. I am not even including the fish. I think I have a separate chart there. And in India, the consumption is less than 10 kilograms. The implication is that I don't know what will happen to Indian consumption pattern if Indian consumers will follow anywhere close to Chinese consumers, which I doubt. But our meat consumption will continue to rise. I think there will be no doubt in that. When that happens, that as remember the conversion from the meat to grain or from grain to meat is 6 to 1. You need 6 kilograms of grains to produce 1 kilogram of meat there. So that could have another serious implication on particularly the Indian agricultural production if we start consuming meat like East Asian region or Southeast Asian region. Thank God we don't. India is largely a vegetarian country, and that has actually helped the Indian agriculture and particularly the entire world agriculture there. If India start demanding a lot of meat, the entire agriculture, not only in India, rest of the region is going to change if that happens. So this is again the fish consumption. You can see the disparity between the fish consumption between China and India. China is close to 70 kilograms. India is slightly above 10 kilograms there. So that will also have implication in terms of food production there. Let's slowly digress to change to the climate change. I think that's one of the pressing issues facing this generation and next generation graduate there. If you are a graduate in agriculture, agronomy, breeding, or anything, even social scientists, the climate change will have serious implication in terms of how the research needs to be done and what kind of varieties we need to develop, what kind of production practices we need to follow there. This is just two graphs to show the carbon dioxide emissions per person. Per person, India is one of the lowest. I think there are a lot of countries beyond, US, China, they're way more carbon dioxide emission than India does. But if you look at the right side, the carbon dioxide emissions, between 2000 and 2020, the percentage change is one of the in India is highest in the region in the world. Although we are low at the base, absolute level, our percentage change in terms of carbon dioxide emission is probably highest in the world. We are 2.2%, China is 1.9%, US is 1.7% declining. So this is something very important as we move ahead in terms of the climate change in the things there. This is also another chart which I found very interesting. If you look at the carbon dioxide emissions at any time in the last 800,000 years, just look at 800,000 years, the carbon dioxide levels were flat until 1950. So look at what has happened to carbon dioxide levels between 1950 and 2024. It has doubled, more than doubled in the last 50 years. So a lot of things happening in the climate change because of man-made. It's mostly done by the man-made things there. So 2024 was one of the hottest year on record. You can see the rise in global average temperature there, and 2024 is one of the hottest uh, year on the record there. I think that is going to continue unless we change our living style or the way we live, the way we. So because of the climate change, we have a lot of frequent occurrence of extreme weather. I look at climate change is more flood, more drought, more cyclone or typhoons there. That's one of the things that happens with the climate change there. So we have a lot of unseasonal weather events there. More warmer winter, earlier springs, late monsoon, increased heat waves, more intense rainfall. We have already seen that's happening, and the rising temperature there. But if you look at how we are going to change it, we have to really, if this is the projected greenhouse gas emission, we have to really reduce our projected greenhouse emission if we want to get that 1.5 degrees centigrade target there. If we don't do that, if we continue with the current policies, the increase in temperature will be 2.5 to 2.9 degrees centigrade. And so if you're an agriculture graduate, this has very serious implication, which is our path of projection, where we are moved ahead. If we are going to, if the temperature going to increase between 2 to 2.9 degree, we have to grow heat tolerant rice or heat tolerant maize, heat tolerant wheat, which will survive in those warming climate there. So depending on the what the world does in terms of the projected greenhouse gas emissions, there are serious implications on the agricultural scientists in terms of developing the varieties and management practices there. So this is the ambitious target of net zero emissions by 2070. So we have very ambitious target, short-term target. We want to reduce annual emissions by 45% by 2030, and we have clearer and more efficient energy sources. But remember that if we want to achieve our target, we need to restore around 26 million hectares and sequester around 2.5 to 3 billion tons of carbon dioxide by expanding forest or any other green cover by 2030 as part of its net zero, our net zero commitment, 2070 commitment. India, for this to happen, India will require an investment of $10 trillion to achieve the net zero emissions by 2070. And the agriculture will have to play a major role in this thing to, if this happens, this becomes a reality and India achieves its net zero target by 2070. Because agriculture is one of the major contributor to the greenhouse gas emission there. So if you look at the Indian agriculture and climate change, we still have 700 million people who depend on agriculture, and many of them are very small and marginal. More importantly, right now, our whatever we have done in the green revolutions, 30% of the land is degraded now. 40% of the land soil is in the poor health. 1/5 of India is facing water crisis, and 70% of water sources is contaminated, primarily because of agriculture there. So climate change will accelerate this whole process there with more severe and more frequent floods and droughts there. So you can see what has happened in India in terms of extreme weather events like heat waves, drought, and floods. In 2023, it's an example of between January and September, India has experienced 235 of 273 days of extreme events there. India also ranks in the top 10 on exposure and vulnerability to the impacts of the climate change. So we are one of the country very much vulnerable to the climate change. In 2021, India suffered a loss of $159 billion due to extreme heat. So it has serious implication in agriculture and beyond there. So all these things led to the lower income, higher hunger and malnutrition there. So the effects of climate change is already being experienced both in India and other parts of the world. So it all depends how we change our behavior going forward. So this is one of the things I was very fascinated that the phenomenon of polar motion, if you know, the earth has shifted 31 inches in the past 2 decades because of excessive groundwater extraction. And India is one of the major contributors of this excessive groundwater in the last 2 decades. And this massive redistribution of water has changed how earth spins. When that happens, when earth is spinning, your season, your climate, everything gets changed. So India is linked to the large share of the water extraction, which we need to change going forward. And most of this groundwater extraction happening for either for rice production, agricultural production there. So we need to develop technology to produce foods with less water, less fertilizer. So to change to reverse the trend, reverse the things happening in the world there. So this has huge implication. This shift in the center of the earth spinning has the serious implication on both altering the seasons and the global climatic pattern there. So whatever we do, main thing is that not only the agricultural production, we need to transform the entire food system there. What I said, the food to the kitchen, or to the dining table there. So agriculture is, as I said, responsible 14% of the greenhouse gas emission. Rice and the livestock are the two major contributor to the greenhouse gas emission within the agriculture. Rice contributes around 17%, fertilizer 19%, and burning of the agricultural residues all kind of contribute together, and agriculture contributes to the 14% of the greenhouse gas emission. So we need to transform the food systems, including the production systems, where many of you will get involved in the production system. That needs to change to alter the greenhouse gas emission, to reduce the greenhouse gas emission. But as an agriculture scientist, you need to be very careful, very attentive to the technology you develop. You cannot just develop a technology. Rice is a major contributor, and this is the technology you develop, and that will reduce the emission, but that has a negative impact on the yield. If your technology has a negative impact on the yield, nobody should adopt it. So any intervention, any technology scientists develop, it should not have no negative impact on the yield. Sorry, no negative impact on the yield. It address supply chain barriers by strengthening the market linkages there. Utilize the people organizations on the ground, the farmer producers group, FPO, FPCs, other things there. So when you go into the work culture, you will hear a lot of buzzword: circular economy, restoration economy, regenerative agriculture practices. So people have given a lot of buzzword to make their things work. So these are all basically coming into developing technologies which are climate resilient or climate smart or climate friendly in terms of what we do. I'll just give an example of rice because as I told you, rice is a major contributor to the greenhouse gas emission because the way we cultivate rice, which is called flooded rice, transplanted flooded rice there. And if you have, I'm pretty sure as an agriculture graduate, you've heard this particular technology, alternate wetting drying, AWD, which was developed by ERI 25 years ago. Now it is getting a lot of traction because if you change rice cultivation from flooded to non-flooded, you can reduce the methane emission there. That's the whole bottom line is there. So this particular technology, you do irrigate rice when it is needed instead of keeping it flooded. It saves water, lower the emissions, low arsenic accumulations, lower methyl mercuries, lower energy fuel consumption. So there are a lot of positives. AWD there. So as a scientist, when you are looking at the technology, you must be thinking, wow, this is the solutions we need to use. Everybody needs to move from flooded to AWD so that we get rid of the methane emission, we save water, we do all kind of good things there. But why it is not being adapted? As a scientist, you need to look at, as I said, the goodness of the technology is not the one side of the story. You need to look at the other side of the story, the economics and other things impact on the yield, whether the adoption will happen or not. This technology has not been adopted because it has a lot of negatives also there. I'll tell you the negatives there. It works if you look at the different conditions there, soil properties. Acidic soil, it has yield reduction of 5%. Alkaline soil, it has yield reduction of 18%. And high soil organic, so it has yield reduction in all the different types of soil. And if you practice AWD throughout the season, there's an 8.1% yield reduction there. So this is from the meta-analysis been done over the years there. So the bottom line is that AWD reduces yield. As I said, if you develop a technology, it has a yield reduction impact, it will not be adopted. Even if it is good for the climate, it is good for the groundwater there. That's the reason this technology has not been adopted. As a scientist going into the work field, you need to make sure your technology you develop has both uh, all these good things on the climate things, but also same time it does not penalize the farmers there. If it is penalizes farmers not going to adopt your particular technology there. This is the AWD impact matrix. You can see in different conditions it has it a different negative impact there. So but the technology is very simple. But if you look at one other thing I was showing, if AWD is practiced under vegetative or reproductive stage, it has no yield reduction. So the technology, just the development is not enough. The educating the farmers also very important, whether they adopt the particular technology or not. Then other thing, I give one example is the DSR versus PTR. The DSR is the direct seeded rice. Ajay, you must be knowing it. The PTR is the transplanted rice. If you look at the DSR versus PTR, the DSR has lot of positive things in terms of the CH4 emission, greenhouse gas, green yield. It has a negative impact, but at the same time, DSR also increase the nitrous oxide, which is also bad for the climate there. And the more importantly, DSR also has a negative impact on the yield. As I said, the DSR and the AWD is very good for the climate perspective. It reduces the greenhouse gas emission, it reduces the water usage there, but it is not being adopted because the negative impact on the yield on average there. It might fit on certain environment, but it is not a global technology that entire 48 million hectares of Indian rice cultivation will come under DSR and AWD there. So I just give example of technology which is the pipeline. If you are a veterinary graduates, you know the livestock is even major contributor to greenhouse gas emission, more than the rice. Now the scientists are developing breeding low methane cattle. The cattle, so some animals produce a massive 30% low methane than other despite the same feed regime. So as a scientist, we need to develop varieties which are more suited in terms of climate smart. So this particular low methane cattle, there's some cattle varieties or breeds. If they're low methane, we need to make sure that the more popular cattle, they're inserted, I don't know how, these low methane genes into other cattle breeds there, so that the in average the methane emission from the cattle will be low there. So, but the challenge is that we need to find the gene responsible for the low methane production. So, some way, if the scientists are able to be successful in finding the gene and can transfer that gene into different breeds, that could have a serious implication, serious positive impact on the climate change. And the more importantly, unlike the grains, unlike the rice, the cattle replacement rate is very high. If this particular, we identify the gene, we can transfer this gene to different cattle breed, within 3 to 7 years, the entire global herd of cattle can be replaced much faster than the rice or other crops there. So as a scientist, you need to think about the technology that could change the whole scenario happening, both climate change, water saving, whatever the emerging issues popping up, to address those particular issues there. So I'm in Vietnam, sitting in Vietnam, and actually we are involved in one of these particular initiatives where Vietnam is developing. Vietnam is a major rice producer and exporters there. Mekong Delta, lot of water, flooded rice they grow. They grow rice 3 times a year. Unlike in India, they grow 3 rice crops a year, and now they are venturing into producing high quality, low emission rice. Adopting technology, DSR, AWD, other technology to produce rice which requires less water, less fertilizer, low emissions, and also the quality is good there. So these are some of the things of the 1 million hectares high quality, low emission rice. I think India, similar things needs to be practiced to bring down the emission and water uses, particularly in the rice. Uh, so I have started one small program in Telangana, where we are targeting 1 lakh hectares of integrated rice export supply chain. So we are developing the one lakh hectares under sustainable rice production practices, and those farmers will be given preference to the export supply chain. So one way you need to attract farmers is to provide them the premium market, give them higher prices, so they can adopt the sustainable production practices there. This is what we are doing from the seed to sip, in terms of the trying to change the practices so that they get higher prices in the global market there. So we are having a cluster productions of 100 to 200 hectares. We give them high quality seed, lower mechanization costs, lower fertilizer use. We establish some modern mills and demo to the other mills there to produce the high quality rice. Train farmers on the sustainable practices, link them with the export market. I have linked them with the Philippines market. So I have made them Telangana sign MOU with Philippines, the largest importer of rice, to export high quality, sustainably produced rice at a premium prices. If you link the market, then the technology adoption happens at much faster rate. If in the end happens, we can apply for carbon credit if more number of farmers adopt the sustainable practices there. So anything so we do, the water savvy technology is a must in terms of what happens. I can skip that one there. So other things I would like to touch base. I don't have time there. We also need to diversify. As an agriculture scientist, the diversification is very important. Instead of producing rice, wheat, grain, we need to diversify into more high value crops, more nutritious crops with less water requirement, less chemical uses there. But this is not happening because a lot of constraint in the diversification there. Our policy environment right now is not suitable for the diversification. Farmers have no incentive to diversify. If you have the MSP in rice, and rice is a very easy crops to grow, farmers still if you look at rice cultivation in India, India is the only country in the world where the rice acreage increased by 8 million hectares in the last 15 years. Every country in the world, including China, Vietnam, the rice acreage declined. But India is probably the only country, primary rice producer, where the rice acreage increased in the last 15 by 8 million hectares. That because of policy setting, our policy environment, our policy frameworks supports rice, encourage farmers to take up rice cultivation. We have the MSP. On top of the MSP, many state gives additional bonus. Telangana gives 500 per superfine. Odisha gives 800 rupees on top of MSP for the any kind of common rice. Jharkhand, Chhattisgarh, many state governments supplement on top of the MSP. That actually encourages farmers to grow more rice. And this is what we have been doing. And that needs to change if we want to see diversification in both India and other countries there. So we have diversification very important. It's very important. We need to do that. But our policy frameworks need to change with the diversifications. So there are a lot of constraint in terms of diversification, why it's not happening. Market access not there. More volatility in price. If you grow rice, you can sell it to the government MSP. If you grow potato, I worked in potato, farmers lose their everything. In some years when the production is more, the potato prices goes to 5 or 6 rupees, which does not cover the cost of cultivation. Tomato I have seen in Bangalore. I have bought tomato 20 kg in 100 rupees in outskirts of the Bangalore there. So those things needs to change. The market stability needs to happen if we want the farmers to diversify from rice to all these crops there. So this is one of the graphs I would like to touch base. In between 1970 and 2014, you don't see a lot of land use pattern has not changed much. Rice used to be 79% in Bangladesh. Now it's 75%. So rice is still dominate the land use pattern. Same thing in India. Rice used to be here, the black one there, and right now 2013-14, the black one. The rice, the proportion of the land used for rice is still the same. In absolute number, it has actually gone up in India. That needs to change if we want to make our agriculture climate smart or climate resilient there. So I can actually, since it's more, I'm already took enough time. I just want to conclude by saying that the agriculture sector at a very crossroad right now. We need to address not only the food security is addressed, it continued to become issue, but now also we have to address the nutrition security. So food and nutrition security. So countless other present issues popping up, declining groundwater, poor soil health, crop burning. Then on top of that, we have the climate change, which worsen the situation already happening. So the climate change is likely to worsen the situation in terms of the frequent flood, drought, rising temperatures, all these different issues there. So food systems must be transformed. Not only the production, the entire value chain needs to be transformed. The example I gave in Telangana, the 1 lakh hectares of integrated supply chain, where we force farmers to adopt the sustainable practices, similar things needs to happen. So the intervention we do as a scientist needs to be carefully calibration happen so that there is no yield penalty there and ensure cost reduction if we want the technology to adopt. So a lot of demand-driven approach should be prioritized over supply push. Before we used to, as a scientist, we develop technology and push it. That doesn't work. You need to find what is needed on the ground, then the develop the technology there. So precise technology targeting and the educating the farmers also very important to reduce the dish adoption. If you want the AWT to happen, you need to educate farmers to do the practice AWD during the vegetative stage, not in all stages of carrier or in the crop growth there. So on the finally the very strong market linkage is required. Any technology adoption happening which are not under MSP, there has to be market linkage. The farmers get a decent price for the crops there. Then there's a new innovating farming models need to come into play because we have millions of very small and marginal farmers there, sub hectares there. They cannot adopt technology on their own. So there need to be different innovative farming model. Production FPOs is one of the example. They could bring 200 farmers together and achieve the scale and give them the bargaining power. So similar bottoms up farming model needs to be adopted where we give the bargaining power for the farmers as a group and give them achieves the economies of scales there so they can adopt technology in terms of the machinery, drone, and other technology which are likely going to come and play a major role. And as I said, the women and youth, they will have to play a key role in the transformation. So as a technology developer, provider, we need to ensure our technology is gender neutral. So we should not develop a tractor that cannot be a woman cannot be a tractor driver. You need to develop tractor which is suitable for the women driver also there. So the rapid spread of the digital technology for innovation and delivery of agriculture products already happening. It's going to accelerate in the future as we move ahead because the labor shortages and all these other things there. With that, let me stop and I apologize for taking little longer. But as I said, it is exciting period for agriculture. If you're an agriculture graduate, you should be looking forward because it is changing now. The agriculture, in particularly in developing country, will change more rapidly because the way the structure of the agriculture is such a way, the number of smallholders we have, the technology adoption will happen much accelerated space there. So I think the agriculture graduate, you need to more innovative there. I think you need to be more thinking like IT graduates. A lot of startups needs to happen. I know the startups 5% success rate is very good, but that's the way the innovation will take place. That's the way I am one of the great example actually. I started with academics. Now I'm a businessman. There is risk in the business, but you have to take those risks there. And the opportunities are endless for the graduates going forward because this is a sector where always will be there. We'll always need food. There is no doubt the food requirement is there. So the technologies has to be adopted. The sector is evolving. So we are in a great space now. If you are in agriculture, the future is very bright, and the job opportunities for graduates in breeding or agronomy or social scientists are endless. The way I look at it. With that, I wish you all the luck in the future. Hope to see you in person sometime in the campus. Thank you.
Thank you, Mohanty, for excellent talk. I know we have a lot of queries and questions. I request members to put in our chat box so that I can pick it up and request him. Later, maybe today we may have limited chance. So any specific 1 or 2 questions we can take. Anybody? Maximum 2 questions. Before I hand it over to Dean Postgraduate Studies, who is sitting next to me, Dr. Mohanty, he also would like to say something at the end. Before that, I'll take a couple of queries, if any.
Sure.
Any questions from students?
I don't see anyway, so that's fine. So I request students as well as others to note down the points and give it to us. We will definitely pass it on to Manti. When he's here, probably I'll request him to join us in person on 14th, if possible. Let's see how things go. Thank you, Manti. I'll request now Dean to say a few words and conclude. Over to you, sir.
Thank you. Thank you, Dr. Nataraj. Sir, good morning and good morning to each one of you. So, in fact, Dr. Mohanty from Vietnam, he has delivered an excellent, the talk on entire the agricultural scenario of Southeast Asia, right from the population in rural to urban areas, and also the factors which are driving the Indian agriculture. So in fact, say I was not knowing the diet diversification is also one of the factor. So this is a really, the alarming situation.
Yeah.
So that according to the requirement of the diet, so we have to plan for our breeding approaches and other technological approaches. And also the implications of the migration of people from rural areas to the urban areas. In fact, you have rightly said that there is a tremendous the negative impact on the agricultural production and also the quality of the produce. Then, as we said, the global middle class population in urban areas is gradually increasing. This might be due to the, due to the economic situation of the middle class population of our country. Then the Asia's share of global GDP. So it is right from you have presented, analyzed, so almost 350 years data. And projected for next 25 years also. It is really quite interesting, sir. Then the food consumption pattern, especially the meat and fish production, fish consumption in China. So compared to, in India, so the fish production, the fish consumption as well as the production have tremendously increased in those, areas compared to India. So which is again a, so important, aspect. Then carbon dioxide emission per person. So in fact, because of the climate change, so there is a change in the, the climatic conditions, rainfall pattern, temperature, humidity, and also even in Bangalore also we are experiencing early monsoon every year from past 4-5 years and early set off for the summer months. So this, has changed even the cropping pattern of our region. So in fact, this is also a very good information, and how the groundwater, extraction has shifted the position of the earth almost 31 inches over the years.
Polar motion.
Yeah, polar
Yes.
motion.
That's very interesting.
That is very interesting. And also, what they have suggested, AWD, alternate wetting and drying technology. So each, this can address these problems. And the 1 lakh hectare model that you have taken up in Telangana. So right from seed to shift, this is an excellent the example so that we can replicate such models. So wherever, it's possible, even in Karnataka also like Mandya and Raichur, where rice is extensively grown as a, the major crop. Of course, throughout your talk, we were attentive. In fact, this is informative, sir. So kindly pass on your, email ID through chat box so that we can circulate it among the students so they can contact directly for any queries. So with this, I thank you for joining from Vietnam. In fact, we were expecting you, your physical present at GKVK campus because of your preoccupied commitments. So you have addressed us from Vietnam. Thank you. Thank you very much. And on behalf of University and Director of Postgraduate Studies, I extend profuse thanks to Dr. Mohanty. Thank you very much, sir.
Thank you.
Thank you, Dr. Mohanty. So with this we will conclude, and I hope you will be here on 14th of this month. That is day after tomorrow.
Sure.
Maybe you're arriving or reaching Bangalore tomorrow?
Yes, I'm reaching tomorrow night. Yeah.
Okay. So then I will call you on 14th morning and see how best we can connect.
Sure.
And it would be great
Sure.
if you join our valedictory function over
Sure.
in
Sure.
person
I'll be
here.
happy.
Yeah.
Thank you. I live very close to TKVK. So
Yeah. Thank you very much, Monty. Bye bye.
thank
Sorry
you.
to bother
Thank
you.
you
I
very
know
much.
we
No, no,
postponed it.
bye-bye.
Yeah, yeah.
No, it's fine. Thank
That's
you.
fine.
Thank you.
Thank you. Bye bye.
Thank you.
Thank
Good
you.
luck. Thank you.
Yeah.
Thank you, students, all participants. Thank you very much.
So let's go back to our
Yeah.
parallel sessions now. Thank you very much.
Yeah.
Bye bye.
Yeah. From tomorrow onwards, please be on time. Before 9:30, please occupy your seats.
Yes.